Example 3-5 is about a trapezoidal cross-section, which carries a discharge of 18.5 cubic meter per second. So Q is 18.5 cubic meter per second. And the bottom width B0 is 6 meter. And side wall slope is 2.5. So for every 1 meter vertical, you have 2.5 meter of horizontal. As you see from the sketch, so we have the depth, bottom width, and side wall slope in trapezoidal channel. So calculate critical depths using figure 3-9 of the textbook, so which we already have it here. And then we can calculate and find the critical depths using the equation for fluid number equal to 1. So the horizontal axis is qm to the power of 3/2. So I call it x, which is this equation. So it's qm to the power of 3/2 divided by g to the power of 1/2 b0 to the power of 5/2. So Q is 18.5 times 2.5 to the power of 3/2 divided by 9.81 to the power of 1/2 times 6 to the power of 5/2. So when you do the calculation from here, you will get x equal to 0.265. Okay, so here we have a log scale. So we have 0.1, and then this is 0.2, and then this one is 0.3. So it is difficult to exactly locate where is 0.265, but let's say that is somewhere here. Okay, so I need just to go up, hit the curve, and then hit the curve here. So this is 0.1, then I have 0.2 here, 0.3, and then 0.4. So it is slightly below 0.4 and way above 0.3. So let's say that the vertical axis, which is y, so from figure 3-9, y is equal to 0. We should say that it's 0.36. Okay, so y is equal to myc divided by b0. So therefore yc is equal to yb0 divided by m. So 0.36 times 6 divided by 2.5. Which gives us 0.864 meter. So this is the solution when you use the graph. So there's a difficulty in exactly locating the value in the horizontal axis because it's logarithmic, and also it's difficult to read the value in vertical axis because it's also logarithmic, but it gives you a good estimation. So the next step or the calculation based on calculation of the Froude number. So we have Froude square is equal to Q square t divided by g a to the power of 3, and it should become equal to 1. So in this case, I'm going to use Excel. So here I have Q, M, B0. So Q is 18.5, M is 2.5, and B0 is 6. So I need to develop through the square. And here is YC. So through the square is equal to Q square to the power of 2 times. So I need to develop the top width. So the top width is B0 plus 2 times M times Y, which is here. And then everything divided by G, which is 9.81, multiplied by area to the power of 3. So the area of a trapezoidal section is B0 plus M times Y times Y. And then everything to the power of 3. Now I just close the parentheses. So I start with YC. So the value that we find from graphical method was 0.864. So this is the value that we calculated from a graphical method. So we want to see that how close our fruit number equation. So you see that our estimation was close, very close, but we can adjust this a little bit. So maybe 0.86, but then it increases the value of fruit number. So it means that I need to increase the depth, 0.87. And 0.87 is a very good estimation. So you'll see that it's very close to 1. If I want to be more accurate, I can put 0.87, maybe 1. And then you see that it's very, very close to 1. Okay.